Welcome to my channel. Myself Ramanari. I am studying in Sri Venkateswara College of Engineering, Bangalore, and today's course title is Network Analysis. Course topic is Classification of Electrical Networks. Classification of electric networks is essential for understanding and analyzing their behavior. It allows us to group networks with similar properties and apply appropriate analysis techniques. This presentation will explore various classifications, providing a comprehensive overview of electrical network types. Passive versus active networks. Passive networks are composed of passive elements like resistors, capacitors, and inductors. They do not contain active elements like transistors or amplifiers. These networks do not generate or amplify power. They only absorb or dissipate power. Active networks. Active networks include active elements like transistors and amplifiers, which can generate or amplify power. They can be used to amplify signals, control circuits, and perform various signal processing functions. Linear versus non-linear networks. Linear networks. In linear networks, the relationship between input and output is directly proportional. The output is a linear function of the input, which simplifies analysis and allows for the application of superposition principles. Non-linear networks exhibit a non-linear relationship between input and output. This makes analysis more complex, and the superposition principle does not apply directly. Time variant versus time invariant networks. Time variant networks. The parameters of time variant networks change over time. This can make analysis challenging as the network's behavior is not consistent. Time invariant networks have fixed parameters that do not change the time. This simplifies analysis as the network's behavior remains consistent over time. Lumped versus distributed parameter networks. Lumped parameter networks lumped networks assume that circuit elements are concentrated at specific points, neglecting their spatial distribution. This assumption simplifies analysis and is valid for circuits with dimensions much smaller than the wavelength of the signal. Distributed parameter networks take into account the spatial distribution of the circuit elements, particularly in transmission lines. This approach is necessary for analyzing high frequency circuits where the signal wavelength becomes comparable to the circuit dimensions. Bilateral versus unilateral networks. Bilateral networks allow signal flow in both directions. Their behavior is symmetrical regardless of the direction of the signal. Examples include resistors and capacitors. Unilateral networks permit signal flow in only one direction. They exhibit directional behavior, allowing signal flow in one direction but not the other. Examples include diodes and transistors in certain configuration. Thank you for watching.